Welcome students to lesson 9 of the natural hazards topic. In this lesson we will be introducing the scientific ideas that will help you to explain why tropical storms happen around the world, where they happen, and the effects that they have on places around the world. You may all have heard the word hurricane. This is the series of lessons that explains them. In this lesson in particular, I'm going to be introducing the scientific ideas behind weather around the world. Please write the date, title and learning objective and have a pen and paper ready to learn. Time to review prior learning. Write 1 to 10, answer the questions from memory and then mark your answers. 1. Secondary effect. 2. Hazard risk. 3 is distribution, that's how something's spread out. 4. Plate boundaries. 5. $5 billion. 6. 525 people were killed. 7. Protection, prediction and planning. 8. Sicily. 9. It's about $3,000. And 10. Base isolation. Remember the rubber pillars. Give yourselves a mark out of 12 because number 7 is worth 3. If you got 10 or more, excellent work. You really understand these ideas. Any questions that you got wrong or missed out, come back to this and test yourselves on them repeatedly until you've memorized them. I'm going to show you 2 photos, and I want you to use the knowledge that you have from previous years to answer the questions. This will help you to be introduced to the topic of today. Here are the photos. So number 1, where do you think they were taken? Well, you should have said this is a desert, a hot desert specifically. You may have said the Sahara Desert, the largest hot desert in the world, in the north of Africa. This photo, a rainforest. You may have heard of the Amazon rainforest, the largest in the world, but this is in fact the Congo rainforest in Africa. 2. Why are there deserts in Egypt? Well, there's something about where Egypt is located in the world that makes it not only hot but also dry. If you watch the Living World lessons and go to the lessons on biomes and explaining why the biomes are located where they are, this will deepen your understanding of this. But it's to do with where air rises and where it sinks and the Earth's angle to the sun, as you will find out more. And why are there rainforests in Brazil? For the same reason. For some reason in Brazil, especially the north of Brazil, there are regularly heavy clouds that form, meaning regular rainfall, leading to rainforests. You will find out why, if you do not already know. And 4, why does it rain so often in the UK? Again, similar to why it rains in Brazil, it rains in the UK because of the presence of clouds. So you're going to understand why clouds form in certain places but not in others, and how this leads to regular rainfall. In this lesson, I'm going to introduce you to a few scientific ideas which will help you to understand future lessons about storms. Let's go. This photo shows the layer of Earth that is based on the air around it. It's a thin envelope of air that surrounds the Earth, and it's called the atmosphere. Please write the word in the definition. This is vitally important for understanding all hazards relating to the weather. Before we move on, you will notice that although the atmosphere stretches all the way up to here, clouds are much lower down and don't reach very high up at all. That's important. Let's go. So what is the atmosphere? Well, this picture shows you the different layers of the atmosphere. It is simply the parcel of air that surrounds the Earth. Hundreds of millions, even billions of years ago, volcanoes that were very, very active in the birth of the Earth some 4 billion years ago were erupting and releasing millions of tons of gases such as carbon dioxide. Over time, due to the gravity of the Earth pulling the gases towards the Earth, these gases built up a layer around the Earth called the atmosphere. Now the Earth is strong enough to hold these gases towards it because gravity gets stronger the larger an object is. That's why the Sun has strong enough gravity to trap planets around it. And the Earth's Earth is large enough to trap a layer of gas around it, which we call the atmosphere. The further away from the Earth you go, the less strong the gravity is, and so the thinner the atmosphere becomes. There's less and less air per meter cubed the higher you go to the very outer layer. The Kármán line here is generally considered to be the outside layer of the atmosphere. There are tiny quantities of air further out, but the Kármán line is usually considered to be the outer layer. We see the northern lights within the mesosphere and shooting stars within there. The stratosphere is the layer that the highest flying aircraft can travel. And the ozone layer below that is the layer that protects us from ultraviolet light from the sun, which would otherwise cause us skin cancer and damage within just a few moments of being exposed to sunlight. All weather on the Earth happens in the troposphere, the lowest layer of the Earth, which extends from 0 kilometers ground level to 15 kilometers above sea level. All weather, clouds and wind happen in this layer here. And that's important, because tropical storms, as damaging and huge as they are limited to this layer, the troposphere. Which brings us to an important idea, and that is density. You may have learned about this in physics or in another science lesson, but density is vitally important for understanding weather in the atmosphere. Think of density as these two cubes. Within this cube on the left you have many, many atoms, or red balls in this case, and within this cube on the right you have far fewer atoms. We say that the cube on the left is denser than the cube on the right. So density means the number of atoms that a substance has within a given area. Since this cube has more atoms within the same area as this cube, it is denser. And why is density important? Well, look at this experiment. You can set up an experiment to show the density of objects. Get a beaker, a glass beaker such as this, and fill it with water. And into the beaker put a sponge, a block of wood, and a piece of metal. The sponge will float right on top of the water, because the sponge is less dense than the water. In this case, the sponge is like this, and the water is like this. The sponge is less dense than water because it's mostly filled with air. Things that are less dense float above, they rise above things that are more dense. If you push the sponge down, it will float back up to the top. The wood is less dense than the water. The difference is not as much as between the sponge and water, and so the wood floats, but it's slightly lower down in the water. By contrast, the metal is denser than the water, and so it sinks. Denser objects sink beneath less dense objects. Consequently, the metal is this in this beaker, and the water is this in this beaker. Density is important for understanding the weather, as you will find out now. Air pressure relates to density. So what is it? Well, you can consider dense air pressure to be density but to do with air molecules. So if you have high air pressure, you have lots of air within a given area. Like here, down at ground level, you have higher air pressure. And at high altitude, at the top of a mountain, you have lower air pressure, fewer molecules of air in the same space. And so air pressure is simply the amount of molecules of air, of oxygen or carbon dioxide or nitrogen, within a certain space, like this box here or this box here. Air pressure is usually higher nearer the ground than at higher altitude because of the Earth's gravity. The strength of the Earth's gravity gets weaker the higher up you go, and so it's less able to hold on to air molecules higher up. What makes air pressure change, and why is this so important? Well, look at these two pictures. These are both air. In this on the left, air has been warmed up. You could say it's been heated up by the sun. As air warms up, the molecules of air spread out. They vibrate a lot more and they spread out further and further apart. And so the air becomes less dense because there are fewer molecules of air in the same space. And so when this warm air is surrounded by cooler air, it rises above it, because less dense objects rise above more dense objects. Consequently, warm air rises above cooler air. By contrast, when air cools down, which it does at high altitude, further from the Earth, for example near the tops of mountains, the atoms and molecules of air come together. They condense. And as they do so, the air becomes more dense. There's more air in the same space. And so, when this cold air is surrounded by warmer air, it sinks. How does this affect air pressure? Well, if you're on the ground and the air warms up and it rises, that means there is now less air around you standing on the ground because it's risen up and it's now away from you, above you. So the air pressure falls around you. If you're on the ground again and cold air is sinking towards you from high up in the atmosphere, then the air pressure rises because now there is more air around you, just as we see here. High air pressure, low air pressure. When you have warm air rising, you have areas of the world that look like this. Rainforests, but generally known as green areas with trees and regular rainfall. In the next lesson you will find out why this happens. Where you have air that sinks, cold air that's denser that sinks, you have places that look like this. They are dry, they have very little rainfall. Although I've shown you a cold example here, Antarctica, there are also hot examples, the world's deserts. Air pressure changes because of a change in temperature to the air, and that change in temperature changes the density of the air, meaning it either rises because it's warmed up or it sinks because it's cooled down. Time to assess learning. Question 1. What is density? Density is the amount of atoms of a substance in a certain area. Question 2. What happens when you put a less dense object in a more dense liquid? The less dense object will float or rise above the denser liquid. For instance, if you put a football underwater and let go, it will float up to the top. It's less dense than the water. Question 3. Why does the atmosphere get thinner, so why is there less air at higher altitudes, further away from the Earth's surface? This is because the gravity of the Earth gets weaker the further away from the Earth you go. And consequently, the Earth can hold on to less air that is further away. And so the atmosphere gets thinner and thinner the further away from the Earth you get. Question 4. What happens to air in the atmosphere when it's warmed up? When air is warmed up, the atoms vibrate, they spread out, and so that air now takes up more space. And so in the same space, there are fewer molecules of air because they've spread out. Consequently, the air is less dense when it's warmed up, and so it rises because less dense objects rise above more dense objects. And finally, what happens to colder air in the atmosphere? Cold air in the atmosphere condenses. The atoms come together. So now there are more atoms of air in the same space. So the air is denser, and so it sinks, because denser objects, such as steel, in a beaker full of water, sink. Time to embed learning. Read the questions, answer them using your understanding, and then mark your answers. Question 1. You need both of these points. Explain them clearly. Question 2. All three of these points needed. Explain them in order. 3. How does temperature affect the density of air? Make sure you explain both of these points as I have. And 4. This is really important. When air is denser, colder, it sinks. So the air pressure near the ground increases because now there is more air near the ground. Air pressure, remember, is the amount of air in a given area. When air is less dense and warmer, It rises, and so the air pressure near the ground decreases because now there's less air near the ground because it's risen up. Please mark your answers. Add in green pen any corrections or parts that you missed. Give yourselves a mark out of the total. If you lost just 2 marks or fewer, fantastic, you've really understood this. From the lesson, write 2 questions, answer them from memory, and then test yourselves in a week's time to make sure that you've remembered this. Next lesson, we're going to further extend our knowledge of the science of weather, except now we're going to look at the whole world.